Yeah, thanks for being here after lunch. I try to be as entertaining as I can to get you out of that soup coma. I hope you have a little bit of a coffee. Yeah, we had that topic about security kind of a little bit through this thing, and we have had that one big topic all the time, right? That one. I want to just throw it out there so it's there. And the question for you is, which one do you look at? From a security perspective, both sides exist, right? You see AI as a threat because it can harm you in a way you never really expected, but it can also be your little helper trying to get things over the line. And I tend to be today in the talk, to look more towards the helper side a little bit, because what we saw in the different talks about designs and how OpenAPI spec works is there was always the notion, there's a good design, and the question for me was, how can we secure it? So one quick slide for me, I'm in that API security business kind of since I feel ages, but it's only 15 years. But my take is not being kind of focused on one thing, but looking at that complex environment, try to find the best solution for what the customer is thinking of. That's why it's always different angles. It's the developer angle, the security angle. Just had the talk up before lunch that was talking about, okay, how do we do TypeScript and security, and kind of a little bit of a drag between the things. And the one thing that struck me was there is this gap between the teams. There's the security teams, and there's maybe a dev team or an API management team, and there are the developers. And actually, in big organizations, they even don't know each other, despite talking. So there is a way, what we try to do is a way to find a way to bridge that gap. So what is good design from an API perspective? It's flat, right? Clear and simple documentation should be good. It should be predictable. I think that's one of the things that a lot of APIs are missing, is this predictability. What happens if? Right, we see a lot of APIs that have a very good, detailed, happy path description. And when it comes down the errors, it says 400, 500, go home. That's it. Right? So the what if is not really expected. That's why error handling, not only gracefully, but actually handling it, is a good idea. From my perspective, yes, it needs to be secure. And for me, security is way more than authentication and authorization. It goes deeper because the guys that try to trick you know that you have an authentication and authorization, so they try to circumvent that problem. And flexible for future changes, that is a topic around versioning, which you can fill a whole day with if you want. For this specific one, that good design is not for the end user. It's not for the public. It's for fellow developers. Your consumers of your API are the same type of people that you are. Think of yourself when you think of APIs. You use APIs from others. And how many times you look at the API description and says, my goodness, can they be a little bit more precise here? Why do I need to do a science project to find out which parameter I need to use? Crazy, right? So one of the things that we from 42Crunch and before the companies I work for actually looked at was, can we have a standard that describes exactly this, in exactly this good design patterns way? And for me, the OpenAPI specification is the one that emerged out of 6 or 7 different ones that came over the decade up. And I'm a fan of API first. Even if you have the API already there, they go through iterations. And you can start with your next iteration by saying, let's document what we have, really document, not just talk about it. Put it into one standard document, and then go from there. For me, the OpenAPI specification is the contract between your consumer developer and your developing the function. If you ever had a contract with an insurance, you know how hard it is if you breach it. And that should be the case how you think about an OpenAPI specification. It's not just development or just documentation. It is your contract. And from a contract perspective, I want to make sure that I understand what is inside, what can I do, what shouldn't I do, and what happens if I breach it. That's the things you put in contracts. So, how do I verify good design? There are plenty of tools. I basically covered them in what we call linting. I spent in one company about 3 months writing OpenAPI guidelines in Confluence. A lot of text. Totally ignored. Completely ignored. Until I found a way to transport this paper document into Spectral rules that I can put into Spectral as a linting tool, and then I could enforce it. And all of a sudden, people start reading it because they were, I don't want to say pissed off, but I would say, that their system didn't go through, that this pipeline stopped them from going forward because it said, no, you're breaking 2 or 3 of these necessary rules, the must-have, so no, we won't move. And that's exactly the point where I want to go with that security. Security is not the pen test at the end of the journey. Security is complex, that's clear, and it's a multi-layered system. That's what we heard at the very beginning. We talk about layers of security, and yes, the API gateways play a really good part of it by securing the parameter and making sure that authorization, authentication is good, certain type of rate limiting. But when you think of zero trust networks for API, an edge case gateway is not enough. What happens from APIs that calls APIs that were called by APIs? You have to break that cycle. So that's why, how do I verify that my design is not only good, but also secure? What mechanisms do we have? And that's basically where the company 42Crunch comes in play. We have that situation where we say, we take your OpenAPI specification. We don't care if the path is nice and easy to read. We don't care if the parameter is well sorted. So everything that LinkedIn is doing, we completely ignore. What we focused on is, can I find already threat vectors inside your OpenAPI spec? And the classical one is the input string. Search string, it's maybe hard to cover because it's open, but everyone has a login page. Everyone has a login API. There's a username. If I say username equals string in my definition, I can start shooting me in my foot right from there. Because if that's implemented this way, I'm actually allowing a username to be 2 gigabyte long string if I want to. And it takes me 2 lines of code as a hacker to throw that 50 times a second at you. Now think about your own backend, login backend. Is that able to cope? Can this understand this? No. So we want to make sure that already in the description, we make sure that is reduced to a meaningful way. Same goes for the code. Now you start developing. Think of API first means I'm doing the design. I hand that contract over to the development team. It starts developing against it or adjusting what exists. That can introduce vulnerabilities. That can introduce new faults. When I'm adding something, it can introduce new problems. So the next thing is about dynamically scanning. Now in security world, there is already dynamic scanning, Dust. But it's based on the idea that you have a web page with links, so you crawl the links and throw everything at it. From an API perspective, that's simply nonsense. If I have a login that has a post and it has a specific path, you can throw hundreds of different passes at this thing. It will never really work because we have a clear design. We have something that we know. So why not checking this specific one and then look at the definition? So I have a string. What happens if I send in a Boolean? What happens if I send in an integer? If I have a restriction of max length 6, what happens if I send 20? The expectation of the scan is not it breaks the application, but what should the application actually do with this? Anything that is from a request perspective, not okay, should result in a 400 bad request. With a meaningful message, not exposing the cold JavaScript stack that says this is crazy, but a meaningful message towards the developer saying, didn't work, right? So that's kind of where we want to go with that. And we want to do it often, constantly, actually, continuously, as part of the CI cycle. Every pull request, every commit, I'm doing this constantly. So I'm not letting them go for 3 months and then say, oh, by the way, there's a security problem. Let's start again, right? So the idea is really do it often. Now reflect all the problems. What's next? That's where API comes in place, because you need to find someone that fixes the problem, right? It's not just done by flagging it, having a nice dashboard with the blinking light saying you have a Ebola problem. That's not helpful. You need someone that fixes it. And that's where we want to dive a little bit into that OpenAI concept. Now it's getting deep technical. Some of you, hopefully, not too much of a worry. That's actually a spec generated by OpenAI, just out of a business context. And you see, username, password, string, because there was no more information for that system. And I was focused on that username because it's a very easy way to explain what we mean. How does the developer know what the username is now? Yeah, he might look up the security thing that says you have a problem. The string is not defined, and it doesn't have a pattern, which would be the 2 ways to restrict that input system. Now, how do I know what's happening? Go one step further. I can say it's an email. Simply, right? I'm just saying it's an email. Should restrict this already, because already the developer knows, okay, now it's not some string, it's an email. But that's still not a pattern. Now, how many of you are able to write a regular expression pattern for emails? That's valid, I would say. Yeah, one hand. That's exactly what it is, 1 out of 100, maybe. So it's not easy, and it's crazy. So here's the point where I come in and says, can that little helper that we talked about at the beginning be of help here, really? And Copilot, which is what it is here, is helping me to do this. I'm just writing, can you give me a valid pattern for an email? That's the answer from Copilot. It's not perfect, because Copilot is not perfect by default. It's lying, it's hallucinating, and sometimes you need to do it 2 or 3 times, but it gives you a pattern that makes sense. Which means 2 seconds after I got that problem, it's fixed. And now with that, I can go through my system and say, next one, next one, next one. And that's what I think is where the system is actually really helpful, not just a threat. The same goes for the other side. Let's do the scan. Let's verify this against a running application. Run this, let's see what happens if I'm scanning it, and the result is, yes, the specification is good. The code, not. Because it's an old code. Who relooks the code of a login after it's written? It's like, it stays there for decades. So same again, how do I get the developer involved? I hand it over to the development team, says, hey, here's your login code from 2010. It's not looking at it. Same problem. How do I get now to a point where it says it should do it as we are told in the spec? Same idea. Written English, change code including input validation to match the pattern. And if not, pull out a 400. That's what it generates, right into the code. So when you think of helping, it's really helpful. It speeds up the process. The only thing that it does not really do, it's not really consistent. As I said, it lies sometimes. So if you write this, you should at least understand what it's doing with you, because otherwise, it's not like it's God's will or something like this. It just says, done. Now, check it. If it makes sense, keep it. Otherwise, change it. I would, for example, change the message. I would say wrong format, not wrong email format. Because that is already too much information I give back to my hackers to say wrong email format. It's like, thank you, now I know it's an email. Right? So it does help, but it also kills you. So can we improve security? Yes, by continuously proving, testing, continuously remediating. With a little bit of a help of a friend, it actually goes faster. And as we are called 40 to crunch, my last slide looks like this. Thank you.